Alright, so question 5 of 2011. At the beginning of 2010, a landfill contained 1,400 tons of solid waste. The increasing function W models the total amount of solid waste stored at the landfill. Planners estimate that W will satisfy the differential equation dW over dt equals 1 over 25 times the quantity of W minus 300 for the next 20 years. W is measured in tons and T is measured in years from the start of 2010. Use the line tangent to the graph of W at T equals 0 to approximate the amount of solid waste that the landfill contains at the end of the first 3 months of 2010. Time T equals 1 over 4. So, we know for a fact that we are trying to find a dW over dt. We're trying to find that at t equals 0. Seems simple enough. So of course, we're going to write out what dW over dt equals. And that is 125 over W minus 300. Of course, we're going to find it in terms of W, so we're going to rewrite that as 125 W of 0 minus 300, which, of course, that's given to us. At the beginning of 2010, a landfill contained 1,400 tons of solid waste. So, W at T is 0 is, of course, 1,400. So, that's 1 over 25. And that's 1,400 minus 300, which equals 1,100 over 25, and that equals 44. So, of course, the tangent line is y is equal to 1,400 plus 44t. And then, of course, we have to approximate. So W is approximately, let's make it more specific, just so the people know. W of 1/4, because it says so in the equation, time T equals 1/4. That's the approximation we're trying to find. So that's approximately 1,400 plus 44 times 1/4, which that will be 11. So this is roughly 1,411 tons, because we're trying to find the tons, the amount of solid waste in tons that the landfill contains at the end of the first 3 months of 2010. So this will also be your answer right here. So the points are distributed. There are 2 points that are found here, which is dW over dt at t equals 0. So that will be what this is right here. That's 1 point. The other point would be the answer, which is the approximation right here. So that's another point. Now, letter B states, find d. Okay, so basically it's saying find the second derivative in terms of W. Use the second derivative to determine whether your answer in part A is an underestimate or overestimate of the amount of solid waste that the landfill contains at time T equals 1/4. So, of course, we're already given what dw of dt is, so all we gotta do is find the second derivative in terms of w. So, of course, we're gonna write it like this. The second derivative in terms of w, not in terms of t, but in terms of w, is 125 times dw dt, which of course we already have, so we're going to put that there so we can recognize what we have to do, and then that will be 1 over 625 times w minus 300. And of course, this is the second derivative right here. So, the question is asking us, use the second derivative to determine whether the answer in part A is an underestimate or an overestimate of the amount of solid waste that the landfill contains at time t equals 1,4. So, we know for a fact also that W is greater than, at least greater than or equal to 1,400, because it was given in the problem. At the beginning of 2010, a landfill contained 1,400 tons of solid waste at the beginning, so we know that W is at least 1,400. So, with that in mind, we now know that d2 of w over dt squared, or the second derivative, is greater than 0 on the interval when t is greater than or equal to 0, but is greater than or less than or equal to 1, 4. Because this is the interval we're looking for, because we're trying to find 1 over 4. So, now, based on all of this, we know that it is part A is an underestimate. Therefore, part A is an underestimate. And there's your answer right there. Now, this question also has 2 points. One lies within finding the second derivative, right here. Boom. In terms of W, so that's 1 point.